Hello, this is Dr. Moyer for FCS 5901, Statistics in Family and Consumer Sciences, and we will be talking about frequency distributions and measures of central tendency in this PowerPoint. You have been assigned to calculate frequency distributions on a homework assignment for this week using Excel, and I want to talk about why those are important and how they're used. It's one of the most common statistics used ever. People may report, just how many in a group of 200, how many people had red hair, how many people had blonde hair, how many people had black hair, brown hair, no hair, etc. And so we use that to report percentages a lot. They illustrate how values are spread out in a data set so you can see how many fall within each of the categories. And frequency distributions are used only typically on categorical data. You can use it theoretically on continuous variables, but categorical variables allow for frequency distributions, make more sense with categorical variables because it shows you the percentage within each category. And although this says SPSS, we use Excel in this class, so don't worry about that. When you're trying to find the range is another common statistic that people will talk about, and that is simply the lowest value subtracted from the highest value. So if you did compute a frequency distribution and you found that the variables ranged from the data ranged from 19 to 56, then the difference between those two is 37. You would report that the range is 37. And we would understand that that's 37 points between the lowest score and the highest score. One thing I meant to point out is that frequency distributions are oftentimes displayed in tables, charts, or graphs. They help, as I just pointed out with the range, identify the lowest and the highest values. They also help us identify any outliers. So if you compute a frequency distribution and you find that you have a value of 8, but none of the categories should be 8 because you only have 4 categories, then that's an error and you would want to delete it. Or it could be the case that you computed the range in an age variable and found out that the ages ranged from 20 to 36, but you have one 73-year-old in there. That would be an outlier, and you might want to eliminate that from further analysis because it's so different from the other ages in the data set. Okay. So here's the distribution, a frequency distribution of the age variable. And you can see why age is a continuous variable in its natural form, meaning if you ask people how old they are. And what we're seeing here is that these are the actual values, and then these are the number of people or cases within that answered like 28. 50 people said 28. 19 people said 1. This is a little difficult to understand when you're talking about age. It would make much more sense to compute the mean or the average and then report what the average age was. That's easier to understand typically for most people, and it is what we do as statisticians for continuous variables. And you did that also this week with the age variable in the Excel worksheet that I gave you. Okay, this is a frequency distribution that is not what we consider a normal distribution. Normal distributions are bell-shaped, and that's because the bulk of people should fall in the middle, somewhere in here. These lines actually represent standard deviations, and we'll talk about standard deviation in a moment, but basically it's just how far on average the scores they were deviating from the mean. So this X symbol here in the middle represents the mean. And if you go out 2 standard deviations on this side, so you went out 1 and 2, and then 2 standard deviations on this side, 1 and 2, this is the mean, so you would add whatever that standard deviation ended up being, you would add the score here, and then you would add it again here, and you would add what's here and add this, you would have 98% or 99% of the cases. More on that later, but this is just what a normal bell-shaped distribution looks like when you're in class and you've taken a test and you want the professor to scale the scores because you think everyone did bad, and he or she says to you, you know, it was a normal bell-shaped distribution. There were a few of you down here that had A's. There were a few of you that failed, but most of you had C's and were in the middle. Even if you don't like that answer, it is normal, and that's what we would expect to see in a normal distribution. A positively skewed distribution would have what we call a tail in the positive direction. So these are the positive numbers would go this way. And it means that the mean is, it's not a distribution that's distributed evenly. The mean is leaning more closer to positive numbers, and it's not a representative sample. And what am I trying to say? It's not a accurate representation because it's not a normal distribution. So you would note that as a statistician. If you went further along in school, maybe some of you are going to get your PhDs, you don't know, you would talk about that in your data. A negatively skewed is just the opposite. You see the tail is this way, so the mean's going to be somewhere over here, more on the negative numbers side. And again, it's just not, it's skewed. It's not a normal distribution. A bimodal distribution means that there are actually kind of 2 means or 2 humps. And you don't typically see this unless you're looking at something like what time of day do car accidents tend to occur? And maybe this is, 8 in the morning and this is 5 o'clock. So they spike twice. It can happen. But what you're really wanting to know are measures of central tendency and how to use them. I'm going to show you how to calculate them, but that's not really the focus because you can have Excel do that, and it's more important that you understand what it means rather than how to calculate it. So we've done the mean, just the average. I'm sure you've done that in Excel before, or you've done it on other things before. The mode is the most frequent value or category in a spread of scores. So it would be the number that occurs the most often. Usually you only calculate that for categorical variables. Maybe you have 3 categories for flavors of ice cream, chocolate, vanilla, and strawberry, and you find that chocolate is the one that the value for chocolate appears the most. That would be the mode. The median is the actual exact middle in a spread of scores. Excuse me. And so in order to do that, you actually have to put the scores in order, starting from lowest to highest, and you would find that middle point. If there's an even number of values, then you would take the 2 numbers in the middle and you would find the middle point between them. If there's an odd number, you're going to have a number that's exactly in the middle. It's a little easier with odd number. So if you're going to calculate the mean, the median, and the mode for this set of scores, then remember that for the median, you're going to have to put them in order. So you would start with 9, and you would list them all the way up to 17. And let me just give you a minute to do that. So to find the mean, you're adding up all of those scores, and then you're dividing them by the number of scores. So we see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So I just counted these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Add all these up and divide by 10, and you'll get 11.8. So that would be the mean for this spread of scores. If you wanted to calculate the median, you'd have to line them up. And so you'd put them in order. And let me just switch out of this for just a moment. Okay, so you're going to put them in order. Let me make this big. We've got 9, 10, 10, 10, 10, 4 tens, 1, 2, 3, 4, then 11, oops, 12, 14, 15, 17. Okay? Remember I told you that you find the exact middle point. So 1, 2, 3, 4, 5. Here's the middle. And you're going to find the difference between 10 and 11 because those are in the middle. So the median would be 10.5. Excuse me one moment. Still suffering from this cold. It's just not fun. As far as the mode, let's go back to this Word document. Good Lord. I am not doing well. What you're going to do is find the value that is reported the most. And so if you were looking at this spread, just get rid of this, you'd see that there are more 10s than anything else. So that would mean that the mode equals 10. So hopefully that makes sense. Calculating the mean, the median, and the mode. And these are the most common measures of central tendency, along with frequency distributions and the range. The standard deviation is a little trickier. To be honest, it's a concept that it took me a long time to really wrap my head around it. So I don't expect you guys to be experts on standard deviation, but I do expect you to understand why we have to report it. And whenever you report the mean, you have to report the standard deviation. I didn't have you guys calculate it this week, but the next time I give you an assignment, you will be doing that. And so it's basically the how far away from the mean the scores are on average. So you're calculating the mean, and then you have a standard deviation, which means there's an even amount. Let me go back to this figure. So this is like 1 standard deviation, 2, and you see how it's standardized. They're equal. So it's on average, like how far away these scores are from the mean, but it's standardized, so it's one number, and when you go away from the mean, you're adding or subtracting a standard deviation. It's kind of the mean is really the best way that I can put it. And it helps you tell the story behind the data. So why is this useful? Well, if you're comparing test scores for different schools, this standard deviation will tell you how diverse the test scores are for each school. Let's say that Springfield Elementary has a higher mean test score than Shelbyville Elementary. And your first reaction might be to say that the kids at Springfield are smarter because the mean was higher. But a bigger standard deviation for one school would tell you that there are more kids at that school scoring towards one extreme or the other, meaning really high or really low. And by asking a few follow-up questions, you might find that Springfield's mean was skewed because the school district sends all of the gifted education kids to Springfield. Or that Shelbyville's scores were dragged down because students who recently have been mainstreamed from special education classes were sent to Shelbyville. So in this way, looking at the standard deviation would help you pinpoint this story and help you to figure out what's going on. Just having the mean would not be enough. I am never ever going to make you calculate a standard deviation by hand, but if you're like me, you need to know the science or the math behind this, whatever it is we're talking about. So I wanted to give you the formula. And in the next slide, I give you some numbers so that you actually apply that, and you find at the bottom that the standard deviation is 6.48. And so that would mean that, let's say the mean is 10, the standard deviation is 6.48, then if you went out one standard deviation from the mean, you would take 10 and add 6.48, and you would have 16.48, right? And then if you take the mean again, which is 10, and you subtract one standard deviation, because this way is the negative side, then you would have, sorry, doing the math in my head, 3.52. So that means, again, here's the mean, 10, 6.48, which came from here, and we calculated it using this formula. If we go out one standard deviation up, we add 6.48 to 10. If we go down one or away, then we subtract 6.48 from 10. And we've got 3.52 over here. And then on this side, we would have 16.48. Okay. If you're with me that far, this is good. You see these numbers in the middle, 34.1, 34.1. If you add them together, you're going to get 68.2. The statistical rule of thumb is that if you go out one standard deviation from the mean in a normal distribution like this, that you are capturing 68.2% of the scores. So you can explain and you can calculate them, figure them out with just the mean and the standard deviation. You don't have to have a whole bunch of data and do a bunch of things. You have it here. This way is going out 2 standard deviations from the mean. And the same on this side. So again, our standard deviation is 6.48. And then we had 3.52. Okay, so you're going to be going out, you're taking 10, subtracting 6.48, which gave you 3.52, and then you're subtracting 6.48 again for another standard deviation. And that's going to give you a negative number, but that's okay. And the same happens on this side. You added one standard deviation and got 16.48. Now you're going to add 6.48 again and get, so then you have gone out 2 standard deviations from the mean. So going out 2 standard deviations in either direction, if you add all of these numbers up, you've got 68.2 plus 13.6 and 13.6. And if you add all those together, you get 95.4. So the statistical rule of thumb is that if you have the mean and the standard deviation and you go out 2 standard deviations in either direction, then you have captured 95% of the cases. And you see there are very few cases here on the end. And that's what a normal distribution is. Like this, you can say, like these could be the A's and these are the F's. But I hope that makes sense. Let me give you another example with easier math. Let's say that the standard deviation is 2 and the mean is 10. So you've got a 10 here. This represents the mean, and this symbol here stands for standard deviation. The standard deviation is 2. 10 plus 2 is 12. 10 minus 2 is 8. So between 8 and 12 are 68% of the cases. They have scored between 8 and 12 on whatever this is. Then if you go out 2 standard deviations, so 10 plus 2 is 12, plus 2 is 14. Whoops. And the same on this side, 10 minus 2 is 8, minus 2 is 6. So the range is 6 to 14. This line here, this line here. And between 95% of the people in the data set scored between 6 and 14 because we know the mean and we know the standard deviation and we're following the rule of thumb. If this doesn't make sense to you, I encourage you to Google it and try to find other people explaining it in a different way, and maybe the way that I'm explaining it. But this is actually a very useful tool, and it's one of the reasons that standard deviations are so important. You know, if you have the mean and you have the standard deviation, you can figure out the range for 95% of the cases. Pretty powerful stuff. This is just laid out for you in text. So in a normal distribution, 68% of the data is within 1 standard deviation, 95 is within 2, and then the third one, which we didn't go over, captures 99%. So if we went out 3, which is way out to here, way out to here, so then we're doing 10 plus 2 is 12, plus 2 is 14, plus 2 is 16, and then we do 10 minus 2 is 8, minus 2 is 6, minus 2 is 4. Then you're talking about 4 being over here, all the way to 16 over here. And that means 99% of the cases are in that range. And that's what this is. So the most useful aspect of standard deviation is that it tells us how spread out the values are, what we call the variance from the mean. So if you're looking at that, you know, and the hump may not look like this. Your data may have a really crazy hump that's just different, but there's still going to always be a mean, and you're going to have standard deviation, so you can go out 1 standard deviation. That doesn't change. So it tells you like how spread out the values are. Oh, I know what I wanted to say. If this hump is really tight, like it's really skinny and tall, that means all the data is clustered around the mean. So there's not very much variance, that the numbers don't range very far. But if the hump is really low and long, then that means the scores are spread out really far. There's a big variance. So you know this by the standard deviation. The bigger the standard deviation, the more spread out the scores are, or the more variance there is. And we always have to have it because you can have 2 means that are the same, but if the standard deviations are different, then we know something about the range of values. If you have a mean with a standard deviation of 0.68 versus a mean with a standard deviation of 4.71, you know that this range is going to be bigger, so it has more variance. This range is going to be smaller and has less variance. This would be the skinny hump. They're all clustered around the mean. This would be the more longer hump. and they're further away from the mean. Why does this matter? Well, what if we were talking about how many times students had admitted to cheating in the last year? We'd know that the scores were spread out further if it was a higher standard deviation versus a smaller standard deviation. You'll get a question like this on your exam, where I will present two means to you with that are exactly the same and two standard deviations that are different, and I will expect you to be able to explain why this matters. Okay? Hopefully that makes sense to you. That covers our lecture on measures of central tendency, and I will post the plain PowerPoint too, so that you can use that and go back and forth between it if you have to listen to this over and over. Remember, you can Google to get other explanations as well. Okay, that's all.